The next part of our simplifying unit is looking at power rules. In order to understand a power, we need to define what it is. First of all, a power could have a coefficient. A coefficient is a number that is multiplied by a variable. So a power can have up to 3 parts. It could have a coefficient. Not all powers have a coefficient, but all powers do have a base. That is what is being raised to the exponent. The exponent is sometimes called the power as well. We are on Learning Target 15, and our essential question is, how do exponent rules work? Starting off with our multiplication rule. First of all, an exponent means repeated multiplication. So just the x is being squared. So I will write x times itself twice. And then just the x is to the 5th power. So I will write the x times itself 5 times. Next, I will multiply my numbers together. 3 times 6 is 18. And then I will multiply all of my x's together. We have 1, 2, 3, 4, 5, 6, 7 x's, which means x to the 7th power.
Hi, how are you today? Bye.
Since I'm recording at home, someone wanted to come say hi. Example B, we'll do the same thing. Multiplying out our 4 w's and our 9 w's. We have negative 7 times 5 is negative 35. And counting all of our w's, we have 4 w's plus 9 w's for a total of 13 w's. Now we're going to look at our dividing rules. We're going to do the same thing and write this out the long way. We have 32 times 6y's all over 12 times 3y's. This time, instead of combining our y's, we're going to cancel our y's. Y divided by y cancels to 1. We can simplify 32 over 12. What goes into 32 and 12 is 4. 32 divided by 4 is 8. 12 divided by 4 is 3. And I have 3 y's left in the numerator, which is y cubed. Example B, same process. We have 7 m's being multiplied in the numerator. All over 2 m's in the denominator. 2 of my m's cancel. M divided by m is 1. 9 and 6 can both be divided by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. And we have 5 m's left in the numerator. Finally, our power rule. When we have a power raised to another power, what we're going to do is first think about all of this being multiplied by itself 3 times. So I'm going to write that out 3 times. And then I'm going to think about my c's being multiplied together 5 times each. Notice the 2 is not being raised to a power, so I will not multiply the 2 5 times, just the c. And then I will multiply. 2 times 2 is 4, times 2 is 8. Be careful with 2's, it's very tempting to count 2, 4, 6, 8 instead of multiplying. Counting 2, 4, 6, 8 is adding 2, but we need to multiply. And then I have 5 c's plus 5 c's plus 5 more c's for a total of 15 c's. Part B, we have 7, and then we have v to the 15th times itself 0 times. Well, that disappears. We have 0 groups of v to the 15th, which leaves us with just 7. And our last example, we have negative d to the 4th times itself 4 times. And again, the negative is a coefficient. You can think of that as -1 times d to the 4th. So I'm going to write my negative sign just once, and then my d times itself 4 times. And I will do that 4 times. And finally, I will multiply. A negative times a negative is positive, times another negative is negative, times the last negative becomes positive again, and then I have 4d's plus 4d's is 8, plus another 4 is 12, plus another 4 is 16, so I have d to the 16th power. All of those negatives canceled each other out, so my coefficient is 1. I wanted to go over the properties of exponents after I showed you how they work so that you would better understand where they come from. You may have noticed that when I had, for example, that last one, when we had d to the 4th times itself 4 times, after I wrote it out the long way, I counted 4d's plus another 4, plus another 4, plus another 4. So my rule is that we can add those exponents together if it came from multiplication. We saw in example 2 that the variables canceled each other out when we had m times m times m divided by m times m. 2 of those m's canceled. It came from m cubed over m squared. We took the 3 minus the 2 if we had division of powers. This one, our last example again, was d to the 4th to the 4th power. After we worked this out the long way, we ended up with d to the 16th, which means we multiplied those powers together. And finally, we did see one example where we had something to the 0 power and it canceled, so we multiplied 1 by the 7. I didn't talk about that explicitly, but right here, all of this turns into 1. 7 times 1 is still 7. And you have 3 U-try questions.